Hello and welcome to video number 3 in this series. In this video I'll demonstrate how properties of fractions or quotients lead to a rationale for simplifying fractions or reducing them to lowest terms. The first property is that two fractions, a over b and c over d, are equivalent if a times d is equal to b times c. So, for example, 3/4 is equivalent to 6 over 8 because 3 times 8 is equal to 4 times 6. 3 times 8 is 24, 4 times 6 is 24. Next, if we have two numbers a and b, and we take the negative of a and divide that by b, that's the same as if we take the positive of a and divide it by the negative of b, and both of those are equal to the negative of the fraction a over b. By contrast, if I take the negative of a and divide it by the negative of b, I get the positive of a over b. So for example, minus 3 divided by 4 is the same as 3 divided by minus 4, and they're both equal to minus 3/4, whereas minus 3 divided by minus 4 is equal to plus 3/4. And finally, if I have a fraction a over b and I multiply the numerator, which is a, and the denominator, which is b, by the same number, I get an equivalent fraction. So for example, if I write that number that I'm multiplying by as c, we've got a over b is equal to ac over bc. So for example, I could have 3 over 4, and then I could multiply 3 by 6 and 4 by 6. I'll have 18 over 24, and 3/4 and 18 divided by 24 are equivalent fractions. And this last property here means that any fraction has an infinite number of equivalent fractions because I can multiply by any number c in the numerator and the denominator. So we have an infinite number of equivalent fractions. There's only one of those fractions, though, that is said to be in lowest terms. And the fraction that's in lowest terms is the one where the numerator and the denominator have no common factor other than the number 1. So for these fractions here, 3 over 4 and 18 over 24, it's 3 over 4 that is in lowest terms because there's no common factor for 3 and 4 other than the number 1. So this kind of begs the question, how do I reduce a fraction to lowest terms? So one way we could think about that is use one of the fraction properties that we discussed earlier, and if I divide now the numerator and the denominator by a common factor, then I'll get an equivalent fraction. So let's say a divided by d and b divided by d. If I repeatedly divide the numerator and the denominator by common factors, eventually I have to end up with the fraction in lowest terms. So to demonstrate that, let's start with 18 over 24 and get it down to lowest terms, 3 over 4. So we'll start with 18 over 24. And first of all, let's divide by a common factor for 18 and 24. So both of these numbers are divisible by 3, so let's start there. So 18 divided by 3 is 6. 24 divided by 3 is 8. Is it in lowest terms yet? It's not, because there's a common factor other than 1 for 6 and 8, which is the number 2. So now I could divide by 2, numerator and denominator. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So now we're finally in lowest terms, because there's no common factor for 3 and 4 other than the number 1. So often we can go from a fraction like 18 over 24, reduce it to lowest terms in a single step. Here I did 2 steps, but if we recognize a different common factor, we can sometimes get there a little bit quicker. So let's do that here. So I could also recognize that 6 is a common factor of 18 and 24. And so sometimes there's a shortcut. Instead of doing all these divisions and writing it out longhand, one way to make this a little bit quicker is to say, okay, 6 is a common factor. How many times does 6 go into 18? It goes 3 times. And then how many times does 6 go into 24? It goes 4 times. And so we've got 18 over 24 is the same as 3 over 4. Another question that arises when we're going through this is, why do we care? So why not just use 18 over 24? The reason we like to have fractions in lowest terms is because these two numbers are smaller. That's essentially the reason. It's easier to deal with the numbers 3 and 4 than it is to deal with the numbers 18 and 24. And so because it's easier to deal with, it's common practice to reduce fractions to lowest terms. This will become even more evident later when we're talking about more complicated quotients, where we're not dealing with numbers anymore, but we're dealing with algebraic expressions in the numerator and the denominator. And again, this idea of lowest terms will come up then. So we typically want to reduce fractions to lowest terms. Occasionally we don't. So there are some circumstances when we don't. And one example would be if we're trying to express a fraction as a decimal. So for example, 3/4. And if we're trying to express that as a decimal, to express a number as a decimal, if it's a terminating decimal, which it is in this case, we actually want the denominator to be 100. So we want an equivalent fraction with 100 in the denominator. So we have to think about, what do we need to multiply 4 by to get 100? So we would need to multiply by 25. And then we'll do the same to the numerator. So we'll get 75 over 100. So 0.75. So sometimes we don't want to end up with lowest terms, but usually we do. So let's run through a few more examples of reducing fractions to lowest terms. So 10 over 15. So first we ask ourselves, is it in lowest terms? So are there any common factors for 10 and 15 other than 1? In this case there are, so it's not yet in lowest terms. So a common factor for 10 and 15 is 5. So if I do 10 divided by 5 and 15 divided by 5, I'll have 2 in the numerator and 3 in the denominator. 9 over 36. So again, is it in lowest terms yet? Are there any common factors for 9 and 36? Well, 3. Both 9 and 36 are divisible by 3. So let's divide numerator and denominator by 3. So 9 divided by 3 is 3. 36 divided by 3 is 12. Is 3 over 12 in lowest terms? Not yet, because we have another common factor, 3 again. So if I divide by 3 again, I'll end up with 3 divided by 3, 1 in the numerator, and 12 divided by 3 is 4, so 4 in the denominator. So I took 2 steps here, but I could have actually got there a little quicker just by doing 1 step. If I'd recognized initially that a common factor for 9 and 36 is the number 9 itself. So 9 divided by 9, 36 divided by 9. 9 divided by 9 is 1, and 36 divided by 9 is 4, so 1 over 4. And one more example, 16 over 12. Think about the common factors for 16 and for 12. So 4, I think, works in this case. 16 divided by 4, 12 divided by 4. 16 divided by 4 is 4, and 12 divided by 4 is 3. And this is known as an improper fraction because the numerator is greater than the denominator. And sometimes, not always, but sometimes we want to express that as a mixed number. So in this case, 4/3. So 3/3 would be 1, and then would be 1/3 left over. So this is the same as 1 and 1/3. So you can see as we go through these examples that knowing your times tables helps a lot here, and knowing when you've got common factors, and you can save yourself a bit of time if you try and find the greatest common factor for the numerator and the denominator. But if you can't think of that greatest common factor, it doesn't matter, you'll get there in the end. It just might take a little bit longer. So I'll finish up with 2 more examples, and I'd like you to pause the video at this point and see if you can reduce these next 2 fractions to lowest terms. So the first one will be 18 over 30, and then the second one, 77 over 42. And you really ought to be able to do these without a calculator. If your instinct is to go to the calculator right away, try and resist that instinct, because it really is going to help the way you work and the speed at which you work if you can start to do these kinds of calculations just with a pen and paper and work them through, knowing your times tables and figuring out the answers without immediately going to the calculator. It will save you a lot of time in the long run. So both of these are very possible to solve without a calculator with just basic times tables. So pause the video now and see if you can do these 2, and then we'll see how you do. So for this first one, we need to find a common factor for 18 and 30. So they're both even numbers, so 2 is a common factor. They're both divisible by 3, so 3 is a common factor. But 6 is actually a better common factor to work with here, because that's the greatest common factor in this case. So let's divide numerator and denominator by 6. So 18 divided by 6 is 3, and 30 divided by 6 is 5. So 18 over 30 is equivalent to 3/5, and 3/5 is this fraction, 18 over 30, expressed in lowest terms. 77 over 42, maybe a slightly more challenging example, because people often don't like their 7 times table, but 7 is the common factor in this case. So 77 divided by 7 is 11, and 42 divided by 7 is 6. This is an improper fraction. The numerator is greater than the denominator, so we might want to go one more step and express this as a mixed number. So we'll have 6 over 6 will be 1, and then we'll have 5 over 6 left over, so 1 and 5/6. And that's all for this video. In the next video, I'll stay with fractions and we'll discuss multiplying and dividing fractions.